Okay, YouTube, in our last video we focused on how to solve polynomial equations. In this video we're actually going to focus on how we could use that in conjunction with radical equations to solve equations containing radicals, or say nth roots more generally. Okay, so the first thing I want to do is actually take a look at the kind of equations that we're looking at here. These are equations that have expressions in x, which we need to get the x out of there inside of the radicand. So what we're going to need to do is go through this four-step process that you see here, and really it's steps 1 and 2 that are the most important, but step 4 is also a very important step. We'll get to it, but let's read through this. It says, if necessary, arrange the terms so that one radical is isolated on one side of the equation. And then step 2 is basically raise both sides of the equation to the nth power to eliminate the isolated nth root. So essentially here what we're going to do on this first equation is I'm going to isolate the radical on the left side, and that way what we can do is, I notice that I'm taking the square root. Notice that our instructions said raise it to the nth root. Well, our n here is 2 on the outside of this. So what we'll do is we'll just square both sides. And you can see instantly how this is going to remedy the situation of having an x inside the radical, because what you're left with really is just x plus 3 on the left. Now, I will admit, I'll be the first to admit, that these aren't my favorite equations to solve just because there are a lot of steps involved. So knowing that on the right here, this x minus 3, we need to square it, this means that we actually have to take this times itself and FOIL that out. So we get x plus 3 is equal to x squared minus 3x is minus 6x's, and then we have a negative 3 times a negative 3 is a positive 9. What you see though is essentially now we have a polynomial equation, which is pretty nice. So step 3 just says this: solve the resulting equation, which we're going to do here. It says if this equation still contains radicals, we're going to repeat steps 1 and 2. So in this next example, you'll see an instance where we're going to have to do steps 1 and 2 twice. But essentially right now, since we have this polynomial equation, let's do this. Let's set it equal to 0 and solve it, and then we're going to go back and check to see if all of our answers work here. So let's do this. If I subtract x and I subtract 3 from both sides, it'd be minus x minus 3. We want to set this equal to 0 so that we have this in general form. So I have x squared minus 7x's, and this would be plus 6 constants. And so you'll notice that I have this quadratic thing that I know factors. As a matter of fact, this would factor into, it looks like here, two numbers that multiply out to be a positive 6, add up to be a negative 7, would have to be a negative 6 and a negative 1. So, knowing that these are our factors, we're going to solve this by factoring, which basically means let's now say this times this equals 0. That we can conclude that either x minus 6 equals 0 or x minus 1 equals 0. And in either instance here, we can solve this. We could say add 6 here, you get x equals 6. And if you add 1 here, you get x equals 1. So I'm going to write this set of solutions here. We say, looks like 1 and 6 are in the set of things that cause my equation to be true. So I'm going to say solutions. Now, I'm going to say solutions, question mark, and the only reason why is because of this. Because we squared both sides of this equation, okay, we squared it. What it did was kind of algebraically introduced another solution to this, where there might just be only one solution to the original equation. So what we're going to do here is we're actually going to check both of these solutions back in the original equation. So this doesn't take a long time. We have x plus 3, that plus 3 is equal to x. And we were able to find 1 and 6. So let's try our 1 first here. And I want you to notice instantly, I mean, we get the square root of 4 plus 3 is 1, which by the way is 2 plus 3 is 1. And I know just right now, I know that 5 does not equal 1. So what we're going to do is we're going to say I'm going to cross this off my list. And what I want to do, at least for note takers, is say that x equals 1 is and what we call this is an extra solution or extraneous solution. Okay, and again, the reason why is because when we squared this, we introduced the 1 as being one of the solutions that works out algebraically, but it doesn't actually work when you check the original equation. Now, for the 6, if we were to check this 6 right here, we would say, well, I really get 6 plus 3, this plus 3, and this is all equal to, well, 6. So we get the square root of 9, square root plus 3 is 6. And of course, square root of 9 is 3. At least its principal square root is 3. So we get 3 plus 3 is 6. And so this actually checks out. We say 6 equals 6. So again, it's really important that you check your solutions. So now, for this second example, I want to kind of move through this quickly, not to waste anybody's time, but we say step 1, if necessary, arrange the terms so that one radical is isolated on one side of the equation. So it doesn't matter which one of these I move, but somebody has to go over to the right side so I can isolate one of these on one of the sides. So I notice here that if I were to just add this expression right here to the right side, it would be gone off of the left, and we would get this new equation that says the square root of x plus 5 is equal to the square root of, now positive square root of, x minus 3 and this was being added to that 2 that we saw on the right side. So what we're going to do is the same process that we did last time. We're going to square both sides, square. And what we get on the left side is pretty easy to figure out. It's just an x plus 5. Now the right side, okay, so here's the not fun part. We actually get to, I won't say have to, we get to FOIL this out. We're going to take it times itself. So I will walk through what we end up with here, but it's really one of our special multiplication patterns since we're taking a binomial times itself. So it'll be, now the first times the first, which is the square root of x minus 3 squared, which comes out to be this, x minus 3. Now, what we're going to get here is positive 2 times the square root of x minus 3 plus another positive 2 times the square root of x minus 3. This is going to be 4 total of these square roots of x minus 3. And then our last term here in our FOIL, we're going to get plus 4. So what I want to notice about this, I'm going to clean it up a little bit here. We say x plus 5. We'll simplify the right side. I notice that this negative 3 and the positive 4 can be combined. So I have x, and then a negative 3 and a positive 4 is a plus 1. And then I have plus 4 times the square root of x minus 3. So what makes this a little bit different is this time I notice that I still have a radical, but notice that you only have 1. See, in the beginning we had 2. Now I only have 1. So our method here is this. Solve the resulting equation, but if it still contains radicals, repeat steps 1 and 2, which step 1 says we're going to get this radical term by itself. So this means that I'm going to subtract x and I'm going to subtract 1 from both sides, minus x minus 1. It actually turns out kind of nicely here because I notice that my x's cancel on the left. I'm left with just a positive 4. And we get 4 equals 4 times the square root of x minus 3. So now I don't want to get rid of this 4, in all instances. In this case, we could actually divide both sides by 4, I notice. But we could square both sides at this point, and we'll get an equivalent statement. So what I'll do is, actually I will divide both sides by 4 here. I'm making a judgment call. Just know that you can do this without doing this step here. I get 1 equals the square root of x minus 3, and now we can just carry out the squaring of both sides. So 1 squared is 1. The right side now is x minus 3, and if I add 3 to both sides, I'm already thinking 4 here. We get x is 4, or at least we think we do. So here's the deal. X is 4, question mark. Our solution set is 4, question mark, because we have to go back and check it. So our original statement said the square root of input plus 5 minus the square root of, we had input minus 3. This is all equal to 2, we think. So let's go plug in our 4 here and here, and we'll get the square root of 9 minus the square root of 1 is 2, which we end up with the principal square root of 9 being 3 and a principal square root of 1 being 1 is 2. So we get 2 is 2. So that's how you'll solve equations with nth roots. Basically isolate the root and then raise both sides to that power and rinse and repeat if you need to. Cheers.